And I'm very pleased to announce this is Steve Pearse talking to us today about innovative development through collaboration. At the end of the session, we will have some time for Q&A as well, so please do hold on to then if you do have any queries. Thank you very much.
Hi, can everyone hear me okay? That's good. Okay. And I would like to say thanks for sparing some time from your busy day. I work for a company called Meyvaert, and the reason we're able to do this presentation today is because last year we won the award for Innovator of the Year at the Museums Heritage Show, and they kindly offered us this spot. And what we're going to do is use this as an opportunity to share some of the information about that project, which really was groundbreaking. But we're also going to use it to illustrate some of the processes that we work through to arrive at a finished project. So it should be quite interesting for everybody who's thinking about future projects. And first of all, what do we do? Well, we are a museum display case manufacturer. We're based in Belgium, and we work on projects around the world. My role is I cover the UK, I cover Ireland, I also cover Australia and New Zealand, which is quite fun once you're there. Yeah. This is our process that we work through when we're running a project. It's 8 simple steps, and each one has a series of very focused levels that you have to achieve before you can progress to the next step. And there's lots of checks and balances built into that. It's kind of design assist process, because as you kick off a project, we need to understand what the designers are trying to achieve. They won't always give all the details. Some of the particular requirements for the project may be very technical, as they were in the one I'm going to talk about in a minute. Then we go through the concept stage. The concept stage of the project is where we make sure that everybody is on the same page. First of all, we'll produce a master case sketch, which you see at the top there. And that's probably the first time that the client team will have seen all the different showcases within their project. On this one, there was just 6, but sometimes there are as many as 300. But you can group them by type, and it starts to allow the project team within the museum to understand their project in a different way too, in the way that we would process all those different case types. And we will then try and design them by group. This particular project is one in Capskill in the Netherlands, and I'll come tell you a bit more about that in a moment. We had development design workshops where the client will explain more about what they're hoping to get out of it. The designers will tell us more about what the specifications are, what the materials they want to use, finishes. We'll provide samples, as you see in the corner there, and gradually get agreement on all those different steps as you go forward. Then as the next stage develops, you get through to a stage where everybody is happy with the concept design of the showcases that you've come up with. And then you move on with, once you've got approval on those, to the detailed design phase. And it's a very technical process. In one showcase, you can have over 3,000 different components. And that allows us to create a bill of materials when we move forward to the purchasing phase. But all the way along, we're bringing the client with us. We're also involving other people with coordination. So when we need to perhaps make sure that the power supplies will be in the right position, or lighting, all of those different things, we're trying to make sure that all the other parties involved are aware of the requirements for the showcase and that we've considered them. And that will also work its way into the program as we develop the project. And then sometimes we'll do samples, prototypes, and mock-ups. And that's a really useful process. The mock-ups doesn't have to represent a whole showcase. In the National Gallery of Ireland, we mocked up the case lighting as they wanted it. And then we showed them how it could be by just changing the lighting to, instead of all being spotlights, having some wash lights with spotlights. And suddenly they were like, this is so much better, but they hadn't thought about it. So we were just illustrating that process. And so it's part of that development, just to make sure that our clients haven't missed an opportunity. And that's really important to us. Also, we'll talk to them about future use of the cases beyond their first project, their first installation. What objects are they likely to want to display, and how they might want to perhaps conserve those, what conservation requirements there might be that are different to the elements that are going in first. So all of that process is fed back and goes into our design process. And that then allows us to move on. I haven't finished yet. It allows us to move on to the purchasing phase once we've got approval on all the detailed designs. This is the project that we won Innovator of the Year for, and it tells a story about these objects which are found underneath the North Sea off the Dutch coast, and they needed to be conserved in a very special way. And to be able to win this award, we had to create a very short video that just tells the story of the project. Some of the pictures in this are from the sort of development phase where we were trying to solve humidity control requirements within a nitrogen case display, which was oxygen free. So, but my video will show you and tell you better than me stumbling through this. So we'll just go to that.
Founded in Belgium in 1826, Meyvaert has been specializing in museum showcase design and manufacture since 1946. We now work in museums and galleries around the world and are frequently faced with new technical challenges for presentation and conservation. Capskill is the museum situated in the Dutch coastal town of Texel. They have a unique collection, including 2 amazingly well-preserved silk dresses that were recovered by divers in 2014 from a shipwreck that sank in 1660. For centuries, the dresses were preserved in silk below the water. A silk wedding dress with silver interwoven into the fabric was found within the remains of a chest, along with a silk satin dress with a floral motif that was virtually intact. These are just 2 of several objects rescued from the deep. These garments are very sensitive to light and oxygen and would deteriorate in any normal environment. Our challenge was to create an atmosphere that was oxygen-free in a constant relative humidity to protect these amazing objects. We developed a process that provides a slightly pressurized nitrogen environment and achieves a constant relative humidity level. The humidity was controlled by introducing moisture into one of 2 nitrogen streams. The system then balances the feed into the case to achieve the required humidity level. This was controlled by a purpose-built software system that ensures that the cases remain at a constant overpressure of 2 millibars at 50% humidity plus or minus just 1%. With an oxygen-free atmosphere of 100% nitrogen. It also generates alarms if the set points vary. The welded case construction and the highly compressed seals ensured that the showcases are extremely airtight. With an air exchange rate of 1% per day, this was necessary to ensure that the cases remained pressurized. Having overcome these challenges and created these unique display environments, the dresses and other objects can now be seen for the very first time in 354 years. Artistic director at Capskill, Carina Hordijk, says these display cases, which have been assessed by the University of Amsterdam in collaboration with the Cultural Heritage Agency for the Netherlands, ensure that the textiles can be displayed without them deteriorating. There are only a few oxygen-free display cases in the world, and then not in these dimensions or quantities. It is innovative heritage management, and we expect that the knowledge we've gained here will also be interesting for other parties.
So it's a project with only 6 cases. Simple then, right? Yeah. But the project team that we worked with was really quite more comprehensive than on a normal project because of the scientific concerns. And the exhibition design was done by Opera and Boas Bar Addon. They would be involved in all the design development conversations with us. But along with them are the scientist team. And we worked with people from the Rijksmuseum and other organizations. And they'd done a huge amount of research on these dresses before the project was launched to be able to establish what kind of an environment would suit dresses that had been in the silt under the sea for nearly 400 years. The challenge of that was amazing. And they concluded it needed to be in a 50% humidity environment, and it needed to be in an oxygen-free environment. And that would then be the closest we could represent within a showcase, but display it without deterioration occurring. And the Capskill team was also very comprehensive, and they were so on board with this project, so willing to help and obliging, collaborating at all stages, so that we were able to make sure that not just the scientific elements were right, but by the end of the project, it would look amazing too. And I think we've managed to achieve that rather well. Our internal team was led by project management, was Peter Verreken, who's also our technical director, who is the right guy to run the whole project, supported by another project manager, Candice, and our lead designer was Rob. And we have a series of other designers who work with him as well. And then the timeline for a project like this, you need to allow for that development process. So you can't just go, oh yeah, we want the cases done by December. You know, we've got to do a program which is going to be so respectful of the considerations for the conservation of these amazing objects. And so we had a research and mock-up stage where we were able to experiment with various methods of creating that humidity level and maintaining it. And it's within like 2%. It's really, really tightly controlled. And then the detailed development stage with the case designs and everything followed through to July 22. And then once you build the cases, there's a whole collaboration period where you're commissioning, setting up. You've got to create the right environment before you can install the objects. You've then got to test the consistency of that environment over a period of time, and then you'll install the objects. And that was intense, but brilliant at the same time. It's nice when it works, isn't it? Yeah. And similar projects to this, where we worked with one of the same scientists from the Rijksmuseum. This is the case. It's a very modest looking case, but it's actually housing Anne Frank's diary. And this is such an important historic object. But one of their problems was in this old house where the building is, the vibration of the huge number of visitors they have was actually a risk to the cases, the vibration between the pages. And we had to solve this vibration issue and still create a very strictly controlled environment. And the way we did that was by building one showcase inside another. Can you see that those are two different showcases? And the outer one was mounted on the gallery floor. And that was really to keep people away from the inner case, and all the vibration would just be transmitted to the outer case. But it's not transmitted to the inner one, because if you look at the yellow part of the diagram, you'll see that went down below the floor level into the building structure. So the vibration of footfall wasn't transmitted through to the object in the case. And so this is the kind of stuff you never imagine, would you? You just go around and you think, yeah, it's a book, you know. But when you really look at the detail in this to solve those problems, and you have vibration measurements, and you have to be able to manage and understand the effects of vibration, and that's quite a specialist field. So that's just one example where we worked with the same scientist, and the same guy again worked with us on this project in Ghent, and our company is based in Ghent. And it's a famous altarpiece called the Lamb Gods, and it's even been in a film recently, The Monuments Men. Any of you chaps who've seen that might remember it. But it's a marvelous Gothic cathedral, and they wanted a case that would have a similar presence, but it's also humidity and temperature controlled with very high security levels. And we managed to achieve all that within this classical environment, and respecting all of the kind of considerations of working in such a location as well. So the collaboration with the client team is also very important throughout that process. There are lots of things that you need to think about when you're developing showcases. And these are all the different kind of topics that you have to just run through with people. The lighting, what is the object? How's the best way to light that? How dim does it need to be? How bright might it need to be? What range of width does the light beam need to cover? And if you're going to change it, what flexibility might you need after that? Shelving, to have some adaptability in that. Object sizes, the weights, the load points, all of that's important to consider. And access, is the door opening big enough to get the objects in? Conservation possibilities. Sometimes if people think they might end up having a more sensitive object in a case, we can build in simple points where you could connect to active climate control in the future. And during case manufacture, that's a very cheap thing to do, just to produce a couple of extra fittings points to connect to. But in the future, if you then needed to connect active climate control, you'd just connect it in. Whereas otherwise, it would mean quite a big sort of intervention to affect those changes. So just thinking about that long-term flexibility all the time. The internal panels and graphics, what are you likely to need? How are they likely to want to change? And perhaps you might need to mount things on the back panels. What load would they be? All of those kind of considerations. And then security. Security aspects are very important to us. That's part of the function of the case. But you also don't want them to change or affect the visual impact of the case or the accessibility of the object. And so we'll work with you to achieve the best opening method with the highest level of security appropriate to the collection. These are a couple of examples which I'd like to just explain. When we first did the this project, on the left, that's the Clockmakers Gallery at the Science Museum. And that particular case on the left was designed with just internal plinths. And they came back to us and said, we'd like more flexibility out of this. We hadn't really allowed for what we'd like to do with it. And so what we designed on the right, that's the same case. And you've got a suspended shelf option. And those are about half the depth of the case, those shelves. But the same shelves will also mount onto a cantilevered bracket system, which is in between the panels, to allow them to be able to have the shelves in a different arrangement, but set further back for larger objects. We also have drop-down fiber optic tails. Can you see those on the screen? They're very small, and they're mounted onto the suspended shelf system. But what it means is if you have a shadow on the lower shelf from objects on the top, then you want to be able to see them. So if you have the drop-down tails, you don't have to use them all the time, but when it's appropriate, you can light an object differently below than from above. You can also use it to highlight the relief on the surface of an object. What else did we do on that one? I think upgraded the lighting in the top too. And then this is our modular demountable showcase system, and that's an example of Goldsmiths Hall did a touring exhibition. That's at Osterley House, but it went to 4 other locations, which were all very different. And the cases are demountable and can easily be rearranged. Those are joined together in pairs. There's 8 cases there joined together. And they've got graphics applied to the outside of the glass, made their own internal tables and everything. This is a toolkit that we made for the project at the Ashmolean Museum in Oxford. And when they were trying to consider all the different ways of being able to display their collection, and this was across the board, that was, the first project was 466 cases. The second one was another 50 cases in their Egyptian gallery. And so they were able to pick and choose from all these different internal options to be able to present the objects well. And that is interesting to see that, but to see it in practice is actually more useful. And here you can see you're able to display something as big as an Egyptian mummy next to a scarab that's just an inch high on the panel next to it. So you bring the objects forward in that particular case. You've got glass shelves with collections on. You've also got label holders, internal plinths. And so all that flexibility is designed in which means in the future, if they wanted to completely strip out that case, you've still got the same principle of removable back panels. You could change those. You could then reconfigure it completely. But you've got a toolkit of parts which are also compatible with all the other showcases within the museum as well. And so you don't necessarily waste those various elements, but you actually then can use them somewhere else too. And that's just part of that process of trying to consider not just what you do now and how you get the best out of that display, but how you might need to consider the future and build that in. And the people who follow us will all thank us for it. Yeah, we don't know that yet, but they will, because we're making their job easier too and saving your organization money. So I hope that's not been too long-winded. We wanted to share our technology from Capskill, and we're happy to talk to you more about that, but also any other relevant conversations. And if you've got questions now, we'll be happy to discuss.
Lovely. Thank you very much, Steve. Does anyone have any questions from the floor? Any hands? Yes, just at the back there. We've got a microphone coming to you.
Hi there. Who is the person? Sorry, can you repeat the person who did that beautiful image of the scuba diver with the dress? I didn't catch the name of the person who created that image. So,
can you tell me the question again? Because I haven't got my earpiece in. Yeah.
The image of the scuba diver with the dress.
Who created that? The museum and their team.
Yes.
Yes. Yeah. And so I can't tell you the creator of that, but my project manager will be able to. I think.
Okay.
Yeah.
Great.
Yeah.
Yes. Sorry.
Hi. Two connected questions with the oxygen-free showcase.
Yes.
You said that there was a 1% loss per day. How was that mitigated, for the next day? So,
Okay.
and what kind of daily maintenance was required?
There was no daily
I
maintenance.
don't need
a
lot of technical details, just...
No, there is a slight overpressure in the showcase, and so it's at 1 or 2 millibars above the surrounding atmospheric pressure. So it is always a positive pressure. That way that the oxygen on the outside can never come in. And so it's designed that process, the pressurized system, that if there will be bound to be microscopic porosities within the seal material and that kind of thing. And so that small leakage is a good thing, because it allows us to be able to introduce fresh gas, which is conditioned with the correct humidity as perhaps surrounding environments change. But the humidity of those cases is just, the graph is just straight. It performs really well.
Thank you.
Lovely. Thank you very much. Any more questions from anyone? No. Lovely. Well, you'll be at booth 2H2
Yeah,
if you do have any
H2,
questions.
yeah.
So please go and have a chat with Steve. And yes, thank you very much.
Thank you.